Hello world, it's Sumit, and in today's session we will going to talk about introduction to machine learning. So this video is particularly for the learners who are very new to the machine learning and trying to understand the different aspects of it. So before getting started, I'm going to give you a brief outline of what we're going to cover up in today's session. So first we're going to see like what is machine learning, where we're going to understand in very theoretical way, like what is it. Then we're going to move on to understand the workflow of it, where we're going to discuss about like right from data gathering to predicting and evaluating the model. Then next we're going to see like the types of machine learning, where we're going to see like in how many types like machine learning can be differentiated and what are the different algorithm associated with each of the classification. Next would be knowing about the terminologies like associated with the types, like how to understand like how many types and what is the use of it. Then at last we're going to jump on to understand the use case of machine learning, where we're going to see the different fascinating project used in real world scenarios. So let's start. What is machine learning? So machine learning is basically a study of an algorithm that improves through experience, and machine learning builds a model that would be purely based upon training data or scene data, and in order to do a prediction that would be on test data or unseen data, and all this happens without being explicitly programmed to do so. And what's the difference between this training data and test data is like, let's say I have an thousand images of an cat, and out of those thousand images I split it into two parts, let's say 70 to 30 to ratio, and those 700 images I take and I'll going to feed my model to make it learn like this are the images of a cat, you have to recognize it, and rest 300 images which I haven't shown it to the model on that unseen data, which we call as test data or unseen data, will going to predict it to know whether that model had learned on training data to predict whether that's the cat or not. So that's how machine learning works. So next is learning about the process of machine learning. So machine learning start with like first step is data gathering, next is data cleaning, third is like selecting the right algorithm, then we move upon creating a building model and finalize it, where we build the model, train it, then at last after training we do a prediction on it, and based on the prediction we have a different strategy. So what happens is like in data gathering and data cleaning, we get as an input as a raw data which we clean it to feed it to our model, and to our model we select the right algorithm, we build the model for our training data to feed into it. So once we're going to train based on upon the training data, we're going to predict on it. So prediction normally happens upon the test data, and based on the prediction we get to know the performance of the model using the different evaluation matrices. Then we define a particular strategy, like whether that particular model is we can use it or not, or do we need to again recreate the model based on upon our the performance of the model. All right, so next is knowing about the types of machine learning. So in this we're going to know the different types of machine learning. So machine learning can be categorized into supervised, unsupervised, and reinforcement learning. So these three are the major types of it, and supervised again can be classified into regression and classification, whereas unsupervised will going to are classified into clustering. So now after getting into deeper into this regression, we're going to have an algorithm. So next layer contains about the number of algorithm each type of machine learning contains. Like for an example, in regression we have linear regression, then in classification we have logistic, decision tree, random forest, k-nearest neighbor, naive Bayes, and support vector machine. And in clustering we have k-means clustering and principal component analysis. So based on the type of the prediction what this algorithm do, we can term linear regression as continuous, whereas all the algorithm which falls under category of classification, it could be categorical prediction, whereas in clustering it would be continuous. Why it is continuous categorical? with that we're going to talk about in later part of the video. In later part of the video we're going to learn about in depth about like what is regression, classification and clustering, and the different terminologies for understanding supervised, unsupervised and reinforcement learning. So for the very beginner, just to let you know, so for example, if I'm taking one algorithm, so one against each of the algorithm I would be creating the two videos. First would be containing about like theory and the mathematical concepts behind it, and the other video would be upon like in Python programming language, where I would be going to create a model, train it, predict it and evaluate the performance of it. Okay, so I hope I had made myself clear on this types of machine learning. So on moving ahead, we're going to see the different terminologies. So we're going to understand the terminologies of it. So first thing is like clustering. So clustering means which one, like out of 2 3 groups, if we had to take up into a cluster, like which one or like in which cluster does it belongs to, or how we can differentiate into different classes, then in that case we're going to take as the clustering. For example, I have a fruit shop, or the vendor have a fruit shop, and he needs to set up his install. So he will going to bring the bunch of fruits. It would be containing fruits or vegetable. Now he have to keep it for display. So keep it for display, he needs to arrange it in a manner so that other person can come and buy. If you're going to keep just a pile of everything at one place, it would be very difficult to choose it from there. All right, so he will going to arrange it. So once he will going to arrange it, that what it's called segmentation. So he had arranged grape into one box, tomato in one, cabbage other, watermelon in other. So he, in this way he had differentiated between each of the fruits in a better way to even for the display purpose as well. So this is what clustering does. Next is about knowing the regression. So regression talks about how much in the sense, for example, if I go to this shop itself and I ask about like if I have to buy a banana, so I'll going to ask them like how much it is, like based on the, or either based on the or like if I'm taking example of an apple. So for an apple, I have, if I have to buy it, I'm going to ask the shopkeeper like at what price I'll going to get it, or like what's the price of it per gram or per kg. So that would be based on the kg, and that it would be predicting the price. So this numerical thing, what we're going to predict it based on the previous data or based on some dependent variable. Here the gram will going to act as the dependent variable, and the independent variable will be our price, what we are about to predict. So this is what regression means. And the third thing is knowing about classification, which talks about what will or like who will. For example, if I had to differentiate between, if either have to buy a fruit or vegetable. For example, the shopkeeper, in one hand he has fruit, on the other he has banana. In one he On one hand he has a banana, on the other hand he has a tomato. So if this falls under category of an vegetable, whereas this falls in the category of fruits. So if I have to differentiate between this, whether I like to buy from either fruits or banana, either fruits or vegetable, then I need to choose between two of it. So that's kind of give me kind of an categorical prediction saying about either whether I'm going to buy the fruit or not, or whether I'm going to buy a vegetable or not. So that's kind of classification, or that kind of prediction what we do in a categorical format. This is what classification means. All right. So on moving ahead, first is like supervised learning. So in supervised learning, what happens is like data set is labeled for every feature or independent variable, and there is a corresponding target data which we use it to train the model. So for example, imagine a class where the teacher has to teach to a student. Teacher knows the entire syllabus, she knows about the entire, she had a entire subject knowledge, but this learning process continues unless the student who have been learning from her or him learns everything from them. Alright, so teacher used to teach them until and unless the student going to understand the particular concept or the subject. For example, in machine learning, what happens is like whatever the data we used to feed to the model has been labeled. Labeled in a sense, For example, if this images, if I am feeding it to the model, so this images would be labeled as cat. So this I am already letting know to my model that this particular image belongs to a cat, and he would be knowing about it. So once I'm going to feed this to the model, so based on the thing what it will going to learn, so based on the input, so the input data contains the annotation, and that what our model learns, and based on that it will going to predict that whether that's a cat or not. So those kind of prediction will comes under as type of supervised learning. Next is about knowing about unsupervised learning. So in unsupervised learning, data set is not labeled in this case, and thus clustering technique is used to group the similar data or among the data points in the same group. Which means, for example, imagine in a class there is a no teacher at all, and student have to learn by themselves. Which means student themselves has to learn everything, and they are upon their own, so everything they had to go by the entire syllabus, they had to learn by themselves. So those kind of thing will to come under as kind of unsupervised learning. Here whatever the thing what we used to feed to the model, for example these are the bunch of images if I am feeding to the model, so I am not going to say to the model like this is dog, this is cat, this is horse. So model, I'm going to feed him the bunch of images, so based on the similar feature it will going to take out the data, and it will going to form a cluster of it. It will going to form like this, it our model will going to form a cluster of all the horses at one place. It will going to group all dog in one group and all the classes of cat in one group. So this way prediction happens in unsupervised learning. Okay, so next is about knowing reinforcement learning. So in reinforcement learning, this is a very special kind of learning where the model learns from each action taken, means the model is rewarded for any correct decision and penalized for any wrong decision, which means it learns to a pattern, and it knows about like what it is doing wrong or right based on the feedback what it is getting, to do kind of backward decision on unknown data. So here what happens is, if I'm going to take the example here, student everything like student have to learn by themselves, either they have to learn by themselves, and it happens over the time. So based on the test results, like what they are getting the marks in the exam, based on the marks they will going to realize like whether they had did a mistake or whether they had to improve. Based on their performance on the exam, they used to like they want to improve themselves. That what the same kind of scenario happens in reinforcement learning as well. To understand that in a pictorial way, for example, if I'm taking the input as a dog, and I'm going to ask my model like what it is, and if by chance like my model says as like and my model is predicting that as a cat, which is absolutely wrong. We know it, like this is a dog but it is predicting that as a cat. So their user will going to give him a feedback to my model saying like you have predicted it wrong. It was a dog but you had predicted that as a cat. So the next step would be model we're going to take the feedback and we're going to note it as kind of a learning process. Here model is learning by his own mistake. Here the model had made mistake. Taking the feedback, model we're going to learn it. So once model we're going to learn it, next time onwards, if you give any unknown data, if I take any unknown data of a dog and I'm going to give it to my model, so model as kind of reinforced response, it will going to return me back a prediction saying about like this is a dog. So based on my past experience, like based on my experience of a model, like what prediction it had did wrong, it will going to take as a feedback, learn, and it will going to perform a reinforced response on unknown data to give a right prediction. That what the reinforcement learning do. And in real world example, if I have to talk about, for example, many of us have an Android phone, we have Google Photos. So in Google Photos, like Google Photos itself, that app itself asks you to label all the data, and based on the label what you predict as, like based on the contact, it will going to segregate it into different faces, and each faces it will going to ask it to identify. So when you going to identify, you yourself are going and marking there as like whether this is a me or any of your friend in your contact list or whatever. So this, you are giving him the data, or like you are giving him the response. So based on that prediction, it is giving you the prediction on the different sets of images like what you're clicking on every day. So that's how the reinforcement learning works. And next is about knowing the use case of machine learning. So this is a very fascinating thing. So we had seen what is supervised learning, unsupervised learning, and reinforcement learning. So knowing about the use case, what we use in our real world example, for example, in classification, we have image classification, diagnostic, or customer retention. So these are the three different basic areas where classification project is been used. For example, in image classification, we do kind of prediction on whether like for example, whether he is wearing a mask or not, whether that is COVID patient or not, whether that is a dog or not, or any kind of categorical prediction what we do. So that comes under classification, and it happens there. In diagnostic, the similar way, it can be used to detect different illness. Let's say for the COVID as well, based on the chest ray, X-ray data, it can predict whether the user has been suffering from COVID or not. Similarly, for the customer retention, based on the previous employee data or something, you can predict whether that particular employee will going to retain in the same company or not. So it could be useful for the HR prediction as well. So in regression, it comes as forecasting, new insight, or process optimization. So in forecasting, we normally, based on the previous data, we predict like how it will going to work, or what the price it will going to give in the future. For example, in stocks or the share market, based on the previous data, how that particular share is been performing on the previous data, like since past when it had got launched till today's date, how that particular share had been performed. Based on the previous data, it can be used to predict on the future thing. Similarly, in the automobile industries, we use new insight or process optimization. Next is about knowing about the dimensionally reduction. So in this we have structured discovery, feature elicitation, meaningful compression. In clustering we have customer segmentation, targeted marketing, or recommended system. So in recommended system, you would be knowing about like we do a kind of clustering where in the recommended system, for example, if you watch any movie in the Netflix, so based on the type of the movie, based on the genre or the kind like what we had watched, so based on the particular keywords, it will going to give you the list of recommended videos to watch, or the recommended movies to watch. That what happens in YouTube as well. Based on the things like what you had watched, based on the keyword, it will going to recommend you the next set of the videos. So it is highly used in our like in real world. It is highly used in Netflix, YouTube, Google, everywhere. And the third thing is about reinforcement learning, where we can see know about navigation, gaming AI, and real-time decision. So in real-time decision, if I have to take the example, I can take the example of an self-learning cars, where the self-learning car is learned from based on like the current experience, or like based, it makes a real-time decision based on the current experience. This robot navigation highly works on reinforcement learning and the game AI. All right. So these are the few fascinating project about the use case of this machine learning. It has been, as of now in today's state, machine learning can be widely applied in almost all the scenarios in across all the domains. Okay. So to summarize like what we had learned about like what is machine learning, where we got to know theoretically like what we had learned between training data and the test data. Next about we learned about the process of machine learning, right from data gathering to creating the model, predicting, evaluating the different strategy. Okay, so next we learned about the types of machine learning, where we saw like in how many different types it can be differentiated, and what are the different algorithm associated with each of the types. Next thing we got to know about the supervised learning, then unsupervised learning, and reinforcement learning. Then we got to know the different terminologies attached with it. Like we got to know the regression, differentiation between regression, classification, and clustering in a pictorial within pictorial example. And at last we got to know the use case of the machine learning. If you liked my video, please do like, share, and subscribe Cuplo on the YouTube channel, and hit the bell notification icon for the new video update. And you can give your valuable feedback as a comment so that I can improve my video and I can come up with a more video like this to help you understand machine learning in a more pictorial way. Thank you.